Guys, on this Saturday, this 2nd January session. Hope you all are doing great. So, dear students, here I am here to present you the session on units and dimensions. So, that is the second session here. Okay, so let's go ahead and take a look at this particular session. I'm just making some small variations here, so kindly wait for some time. Yeah, now as we all are already aware of Unacademy YouTube live session, my dear friends, so let's go ahead and take a look at this session, that is units and dimensions. This is session number 2. Yesterday I have covered one particular session wherein I went ahead with certain basic fundamentals. Okay, on the basis of these basic fundamentals, now I'll be moving further with my discussion. Okay, so now let's go ahead and take a look at our discussion on units and dimensions quickly. So as we all know, this is Happy New Year. So let me just go ahead and wish you all a very happy new year, my dear students. Now this is my brief profile. My name is Uttam Kumar Umarji. I'm an MTech graduate having a 19 year of experience. Okay, so total of 19 years of experience in teaching physics, and presently I'm number 2 educator in Karnataka CET. And to unlock your plus subscription, use the referral code Uttam Live. Okay, fine. Now let's progress with what Unacademy has to offer. What Unacademy offers us. Let me just go ahead and take a look at that. Unacademy has a plus subscription plan for you, my dear friends. And here we have best plans for Karnataka CET 2021 aspirants. And each one of you are aiming for Karnataka CET 2021 this year. So accordingly, you all can go ahead and avail this beneficial Unacademy Plus subscription, my dear friends. So here we have initially a 12-month plan. Now this is a 1 year plan actually. So this is a 12-month plan, and this 12-month plan would cost you 12,375 rupees. Okay, and you can also avail a monthly installment of 1031 rupee per month. Okay, and then you can go ahead with a 6-month plan. Now the 6-month plan would cost you 10,125 rupees, and here if you want to avail monthly EMI, go ahead with 1,688 rupee per month. Okay, then we have a trial plan that is for 1 month only. Okay, so this is purely for new subscribers. Only new subscribers can go ahead and use this trial plan. Now this is a 1 month plan which would cost you 2,250 rupees. Okay, so my suggestion would be like, go with a minimum of 6-month plan. Okay, and then you just look at your performance based on our plus subscription. Okay, then definitely I can say that you will definitely be a winner. So this is my promise to you on behalf of Unacademy. Fine, now if you just take a look at what we get out of it. Okay, we will get a premium content, okay, at affordable price. Then structured live courses are there. You have, okay, and you have dedicated live doubt clarification sessions. You have, then quizzes are at regular intervals for self analysis, my dear friends. Okay, then batches are there for complete preparation, and here test series for DPPs, full length mocks, okay, etc. with analysis would be given to you. This is most important again. Then I can say one single subscription, you will get what? Unlimited access. This is the advantage of being on Unacademy platform. Okay. For example, as you can see, you are listening to and watching to the class from a faculty who has worked really hard in the field of entrance exams for almost like 19 years, and then you are listening and watching his lectures. Look at this, okay, look at this advantage of being on an academy. What if you enter into plus subscription? Then definitely I will be considering some top class sessions on plus subscriptions. Okay, so this is an academy, and this is what I mean here. So comprehensive batch will be live for complete syllabus preparation, my dear friends. Okay, and use the code Uttam live here, okay, to avail a 10% discount. To avail a 10% discount, use Uttam live as your referral code. Okay, so with this note, I'm just going to begin with my discussion session on units and dimensions here. Okay, so shall we go ahead and do that? Let's do it now. Okay, so this is our first question, my dear friends. The question reads is, in the equation p plus a by v square into v minus b is equal to constant, the units of a is, okay, so here are the options that we have. Okay, so we should find the unit of a, that is that has been asked you. Okay, now as you can see here, I'll be considering this equation once again. P plus a by v square into v minus b is equal to constant. Now as we know that dimensions, similar dimensions can be added or subtracted, okay, as well as principle of homogeneity. Now these are two concepts that I'll be adopting here. So concept would be what? Same dimensions can be added or subtracted, and principle of homogeneity. Now these are two concepts that I'll be using in this particular situation. As you can notice here, p plus a by v square. Obviously, a by v square must have the same dimension as that of p. P means pressure here. Okay, so that is what we will write here. So hence, dimensions of p must be same as dimensions of a by v square. So hence we can write, we can comfortably see that. I'll just erase this part. Okay, now we can comfortably see that here A, hence A can be written as pressure into square of volume. Okay, so over here pressure has dimension of m L raised to minus 1 T raised to minus 2. Okay, then volume square is L cube whole square, which is L raised to 6. So if you just work this out, we'll get this as m L raised to 5 T raised to minus 2. Is it not? Okay, so once I have obtained this, unit can be written now. The unit can be written as gram centimeter to the power 5 into second per second square. Right? So here I'll convert this first part into like gram centimeter per second square, and another centimeter to the power 4. I'm writing it outside here. Now, what is gram centimeter per second square? It is the unit of force, that is in CGS system force is measured in dyne, so hence that is equal to dyne centimeter raised to 4. Okay, so this is what we have as our answer here. Okay, I hope it is clear. Now let's progress with next question. Now question number 2 here. So as you all can see, second question, what it reads. Now if x is equal to at plus bt square, okay, where x is the distance traveled by the body in kilometer while t is time in seconds, then the units of B are, okay, fine. Now the units are given like this. Okay, so let me just go ahead and solve this question quickly. Now, as we all know, we have x equal to at plus bt square. This is the equation given to us. Now I'll adopt principle of homogeneity. That means dimensions on left hand side must be same as dimensions on right hand side. So accordingly, from principle of dimensional homogeneity, I can see that x is equal to at and x is also equal to what? Dimension of x is also equal to what? Dimension of bt. So therefore, b is equal to, I can write x by t square. Is it not? And over here, x is what? X is displacement and t square is square of time. So definitely I can write this as unit of b can be written as what? Kilometer per second square. Okay. So kilometer per second square is the required answer here. I hope it is clear. Fine. Now let me just progress to next question. That is question number 3, my dear friends. Okay. Now the question number 3, it reads as the unit of absolute permittivity is. So here we have farad meter, farad per meter square. Option D, farad. Okay. Now if you just concentrate here. Now I'll make use of the capacitance of a spherical conductor formula. Okay, it is given by C is equal to 4 pi epsilon naught into R. So accordingly, epsilon naught is equal to, I'll get this as what? C by 4 pi R. Is it not? Okay, so thus here I can write this as, by substituting the unit of capacitance and radius, then obviously 4 pi does not have any unit because this is a number. So this does not have any unit, right? So accordingly, I can write epsilon naught is equal to farad by meter, farad divided by meter, or it is farad per meter, right? So farad per meter is the SI unit of epsilon naught, that is absolute permittivity. Okay. Now let's progress with question number 4 here. Now, unit of Stephen's constant is, okay. Now they have given like this options. Now to find Stephen's constant, I'll make use of Stephen's formula. Stephen's formula is heat radiated per unit area per unit time is directly proportional to fourth power of absolute temperature, and therefore Q by AT, that is heat radiated per unit area per unit time, is equal to sigma into T raised to 4, absolute temperature power 4. So accordingly I can see that sigma will become equal to what? Q by A into time into fourth power of temperature, absolute temperature, right? So thus unit of sigma is, heat has unit of what? Joule. Then area has unit of meter square, right? Then time, obviously it is in second, right? Then T raised to 4 is what? Kelvin raised to 4. You can comfortably say that. Okay. So hence I can write the final unit as joule per meter square per second per Kelvin raised to 4. And also joule per second is watt here. Okay. So hence I can also write this as watt per meter square Kelvin raised to minus 4 per Kelvin fourth. You can also write like this. So this is regarding unit of sigma, my dear friends. Next question. The SI unit of universal gas constant, capital R, is, okay. So to find universal gas constant, I make use of ideal gas equation. Okay. Now over here we can write PV is equal to nRT, that is ideal gas equation, and thus I can write R is equal to PV divided by N into T. Is it not? So over here I can comfortably mention this in my next step as I have written. As you can see here we have, okay, then dimension of P and dimension of V I will write, then I will get this as ml raised to minus 1 T raised to minus 2, which is pressure, okay, then volume has L cube dimensions, okay, then N is number of moles, so I'll write mole here, then T is Kelvin, I'll mention that, capital K. So thus I'll get this as ml square T raised to minus 2 mole Kelvin, okay, mole K. So definitely ml square T raised to minus 2 is the dimension of energy or work. So hence its SI unit is what? Joule per mole per Kelvin. Joule per mole per Kelvin. So this is the required SI unit, my dear friends. Fine. Now let's progress to sixth question. X is equal to 3yz square. Find the dimensions of y in MKSA system if x and z are the dimension of capacity and magnetic field respectively. Okay. Now over here, firstly I'll write back the given equation, that is x is equal to 3yz square. Now over here y, hence y will be equal to what? X by z square. Now x is given as what? Capacitance, and z is given as magnetic field, so its whole square I am writing. Then accordingly, now capacitance, its dimension I can find by using E is equal to Q square by 2C, or C is equal to Q square divided by 2E. Therefore C will be equal to what? Dimension of Q is time into electric current, T into A whole square. Then energy has dimension of what? ml square T raised to minus 2. So if you just adopt this, then we can see that we'll get this as m raised to minus 1 L raised to minus 2 T fourth A square. Now these are the dimensions that we have. Okay, so thus capacitance dimension I have found. Now let's talk about magnetic field. In order to find dimensions of magnetic field, I'll make use of F is equal to QVB. Now according to this, hence B can be written as F by Q into V. Okay, F is force here, Q into V. Now therefore dimensions of B is equal to dimensions of force is equal to what? M L T raised to minus 2. Then dimension of charge, already I have mentioned this, it is T into A. Okay, then dimension of velocity is L T raised to minus 1. So accordingly I'll get this as M T raised to minus 2 A raised to minus 1. Now these are dimensions of magnetic field, right? So accordingly, therefore y is equal to x by z square we have, right? So hence I'll write all the found out dimensions of capacitance, m raised to minus 1 L raised to minus 2 T fourth A square divided by m T raised to minus 2 A raised to minus 1 whole square. So if we just simplify this, we'll get the dimensions of y as m raised to minus 3 L raised to minus 2 T raised to 8 and A raised to 4. Okay, so simple. So this is the required dimension, my dear friends. Hope it is clear. Now seventh question. Dimensions of mu naught epsilon naught, where symbols have their usual meaning, are. Okay, now remember we have these dimensions given to us, huh? So let me just explore this in one way. velocity of light in vacuum, it is equal to 1 by root of mu naught epsilon naught. Now this is velocity of light in vacuum. So accordingly, 1 by mu naught epsilon naught becomes equal to what? Square of velocity. Because if you square on both sides, this square root will go off, right? Hence, I have written like this. Then accordingly, therefore, dimensions of 1 by mu naught epsilon naught will be equal to LT raised to minus 1 whole square it is, because C has dimension of what? LT raised to minus 1, right? So dimension of C is LT raised to minus 1, its whole square. That's what I am writing. So accordingly, it will be L square T raised to minus 2. Okay. Let's progress with question number 8 here. Now, question number 8. If L, C and R denote inductance, capacitance and resistance respectively, the dimensional formula for C square L R is. Okay. So let's go to the solution to this question. Now this question you can solve it like this. Now firstly, frequency of LC circuit, when we calculate, it is given by F is equal to 1 by 2 pi into root of L by root of LC. Okay, so this is frequency of LC circuit, inductor capacitor circuit. Then therefore 1 by frequency is what? Time period. Therefore time period is equal to 2 pi into root of LC. Okay, so this is one interesting thing. We will see why I have done it like this later. Next, hence LC equal to what? Dimension of L into C is equal to what? T square. Dimension of T square. Is it not? Then similarly, L by R gives the time constant for LR circuit. So accordingly, L by R will be equal to what? Time T here. Okay. So thus C square L into R, I will write it like this. C square L into R equal to C square into L square into R by L. So what I have done, I have simply multiplied and divided by L here. So into L divided by L I have done. That's all. Okay. So I hope it is clear. So let me just erase this. Okay, fine. So I have done like this. Next step. Now this can be written as LC whole square into R by L. Is it not? Now LC whole square into R by L is equal to what? LC whole square. What is dimension of LC? T square. So T square whole square I'll write. Then dimension of R by L is what? Reciprocal of L by R. Hence it is T raised to minus 1. So therefore I'll get this as what? T cube. Is it not? So I'll get the dimension as m raised to 0, L raised to 0, T raised to 3, okay, and A raised to 0. Now this is the dimension that we are supposed to find. So we have found that. Fine. Now let's progress to question number 9. The position of a particle at time t is given by the relation x of t is equal to v naught by alpha into 1 minus c raised to alpha into t. Okay, where v naught is a constant and alpha is greater than 0. The dimensions of v naught and alpha are respectively. Okay. First step, I'll write back the given equation. Okay. Now remember, any exponent or exponential function has zero dimension. Okay. So hence we can say that from principle of homogeneity, alpha into t is dimensionless. So from that I can say that m raised to 0, l raised to 0, t raised to 0. Right? That is, it is equal to 1 here. So therefore, I can write alpha is equal to 1 by t. So this indicates that alpha has dimension of what? T raised to minus 1. Is it not? Okay. Then next step, similarly, I can write x equal to v naught by alpha. Dimension of x equal to v naught by alpha, because if you just multiply v naught by alpha inside, we will get this as what? V naught by alpha into 1 minus v naught by alpha into c raised to minus alpha t. Is it not? So hence I can write this as v naught by alpha dimension. So therefore v naught is equal to what? X into alpha. Is it not? So therefore x has dimension of L and alpha has dimension of what? T raised to minus 1. We only have found it. So I'll substitute that. Hence V naught will be equal to what? L T raised to minus 1. Okay. So hence dimension of alpha is what? T raised to minus 1. Dimension of x V naught is what? L T raised to minus 1. That's it. Now let's progress with ninth question now. Number of particles is given by n equal to minus d into n2 minus n1 by x2 minus x1, crossing a unit area perpendicular to x-axis in unit time, where n1 and n2 are number of particles per unit volume for the value of x meant to x2 and x1. Okay. Find the dimensions of D called as diffusion constant. Okay. Now, as given, I am writing here. Since n is given as what? Number of particles passing from unit area per unit time. Okay. So that is equal to what? Number of particles divided by area into time. Is it not? That is nothing but what? Number of particles does not have any dimension. So obviously it will be m raised to 0, l raised to 0, t raised to 0. Then area has dimension of what? L square. Then time is capital T here. So accordingly I will get this as what? L raised to minus 2, t raised to minus 1. Right? So accordingly, now in the same way, n1 and n2 both of them are equal to what? Number of particles in unit volume. Hence straight away I can write it as what? L raised to minus 3. Is it not? So hence, now from the given formula, now let me just write the given formula. Dimensional equation I am writing here. So negative sign is not required. So hence dimensions of D is equal to dimensions of n into dimension of x2 minus x1 divided by dimensions of n2 minus n1. Now remember, n2 and n1 both of them have same dimension. x2 and x1 they both of them have same dimension, and x2 x1 have dimension of length here. Okay. Whereas n2 n1 it is l raised to minus 3. So that I have already mentioned it to you. Now if we substitute like this, then we tend to see that we'll get this as L raised to minus 2 T raised to minus 1 into L divided by L raised to minus 3. Okay. So thus upon solving this, we'll obtain it as what? We'll obtain this as L square T raised to minus 1. Simple. Is it not, my dear friends? Okay. So dear friends, with this note, today's time is up. So I hope today's session was quite clear to you all. Okay. I'll meet you back in my next YouTube session on Unacademy platform. That is tomorrow. Tomorrow I'll be back with one more interesting session. I'll be starting with motion in one dimension. Okay, so with this note, I'll close my today's discussion, my dear friends. I will see you back tomorrow at 3 p.m. Thank you. Have a wonderful time. Have a wonderful day ahead. Thank you. Your teacher Uttam Kumar signing off. Thank you. Bye bye.